In section 8.2, we'll be looking at some special right triangles. These special right triangles are when we have 45, 45, and 90-degree angles in our triangle, like this picture here, or the other case where we have angles of 30, 60, and 90. These are always going to give us a certain pattern to find a missing side. So the first one we'll look at is the 45, 45, 90 triangle, which will always follow this pattern. Since it's 45 and 45, we already know this is an isosceles triangle, so these two sides are the same, x and x. The other side will always be whatever that number is multiplied by the square root of 2. If I wanted to go backwards, then I could take whatever this number is and divide it by the square root of 2. To prove this, we can just look at this as a right triangle where my legs are x and x. That would give me x squared plus x squared is equal to my third side. Let's say we don't know this yet and we're just calling it c, then it would be equal to c squared. So if I'm solving this for c, we could say c squared is equal to, adding these two parts together would give us 2x squared. We can take the square root of each side, and since the x is squared, we can pull that out of the radical, leaving us with x square root of 2. And so we can see that that third side is whatever number I had, and then multiply by the square root of 2. So if I added 2 here, this would be 2 square root of 2. 3 here, this would be 3 square root of 2. And so we just want to remember that pattern. If this is 1, we multiply by the square root of 2. Those two sides will always be the same. So in this problem, if we're looking for the missing lengths, if this side is n, we note the 45, 45, 90, which means this side would be 9. And then to go from our leg to this side, we just multiply by the square root of 2. So our h is equal to 9 times the square root of 2. If we wanted to be more exact than that, we could put that in our calculator and get a decimal value, which would be about 12.7, but often we just want the exact answer because we might need that later. We could just leave it like that. In this one, same thing, except notice this time we're given the hypotenuse, so I need to work backwards. This is the longer side, so in this one I'm going to need to divide by the square root of 2. So my x is equal to 6 over the square root of 2. We're not allowed to leave radicals in the denominator, so I can multiply this times the square root of 2 over the square root of 2, or 6 square root of 2 over, these multiply to give me 2, or 3 square root of 2. And that could be my answer if we're looking for an exact answer. Or we could have put this into our calculator, round to the nearest tenth, about 4.2. A 30, 60, 90 triangle is similar. There's a ratio that always works. It's x, 2x, and x square root of 3. Or we think about if the side is 1, then the hypotenuse would be 2, and the longer leg would be the square root of 3. To prove this, we actually want to look at a equilateral triangle. So if this is my 30, 60, 90 triangle, notice that I could put this inside of an equilateral triangle or kind of reflect it on itself. If this side is x, this would also be x, which would give me another 30, 60, 90 triangle over on this side. Now I do that because now this side we can see is 2x. If all those angles are 60 degrees, that means that this side over here would be 2x. Now I can get rid of this picture here, and I'm just left with that x and 2x. Now I have a right triangle to work with. In that right triangle, we can see the missing side is this side over here. I'll call that a. So we'll go with a squared plus my other leg, x squared, is equal to my other side squared. Now be careful here, this is 2x squared, but we're squaring the whole side. So put that in parentheses, that's going to give you 4x squared. So subtracting that x squared, we're left with 3x squared. And if we take the square root of each side, 3x squared is inside, we can pull the x out, giving us x times the square root of 3. And so my third side over here, rather than writing it as a, we could think of whatever our length is times the square root of 3. So if we know this side, we can double it to get this side, or times 2, or multiply times the square root of 3 to get this side. If we're going the other direction, notice this way we would divide by 2, or maybe this way we would divide by the square root of 3. So it all depends which direction we're going. So it's a good idea when we're solving problems like this, think about, first of all, just sketch a quick triangle. Remember the shortest side is 1, the longest side is 2, and then the other side somewhere in between there, square root of 3. And we just need to remember what we need to do to get from one part to the other. In this first problem, we were saying BC is 14. That's my hypotenuse here, we look over here and notice that that's my 2. I want to go back to the shortest side first. That'd be the easiest thing to do. So coming this way, I'm going to divide that by 2, and we can see that BA is 7. If we want to find AC then, going in this direction, notice that's going from 1 to the square root of 3 here. And so that's going to give me whatever this number is times the square root of 3, which is 7 times the square root of 3 for AC. And so my AC is equal to 7 square root of 3. For part B, we are given this time AC, which is this side here, 8. And so if I'm going back this time, we notice that right now we're at the square root of 3, so I need to be going in the other direction. I need to divide this by the square root of 3 here. So dividing by the square root of 3, that gives me that BA is equal to 8 divided by the square root of 3. If we want to rationalize our denominator, we'll get 8 square root of 3 over 3, or we could say that that is about 4.6. Now going on from there, we want to use exact values when possible. We could just leave this as 8 over the square root of 3. We know that this side here then, we're going around this way where it's getting longer and it's twice as big, so we're going to multiply that by 2. It gives us 16 over the square root of 3. And so my BC, if we wanted to also rationalize the denominator here, times square root of 3 over square root of 3 would be 16 square root of 3 over 3 is our exact answer, or we could round that to about 9.2. So these are the two things you need to know from this section. Make sure you memorize the relationships, and don't just assume because it looks like these that we're always using these ratios. Always look to make sure, do we actually have 30 and 60 degrees here, or do we actually have 45, 45, 90 triangle, and then you can apply these theorems.